So, if you're looking to get into software quality assurance, there's one idea you've absolutely got to know inside and out: the levels of testing. Today, we're going to break it all down with a super simple blueprint.
And to really get this, I want you to do something for me. Just for a second, forget about software. Instead, I want you to imagine you're building a house, with actual bricks and mortar. How would you make sure it's built to last?
You wouldn't wait until the very end, until the roof is on, to see if the foundation is any good, right? Of course not. You'd check the quality at every single step. First, you make sure every single brick is perfect. Then, as the walls go up, you check them. Once it's all built, you inspect the entire house. And finally, the person who's going to live there, the owner, does one last walkthrough before they take the keys.
Well, believe it or not, that exact same logic applies to building software. This step-by-step approach to quality has a formal name, and it's the blueprint we're going to follow to understand software's four-story house.
It's officially called the levels of testing. Really, it's just a structured approach that says, hey, let's test this thing in phases while we're building it. The whole idea is simple, but trust me, it's incredibly powerful. You ensure quality bit by bit instead of waiting to test everything in one big chaotic mess at the end. So why is this such a big deal? Well, think about it. Finding a bug early is like finding one cracked brick. It's cheap, it's easy to replace, no problem. But finding that same bug after the whole application is finished? That's like finding a major crack in the foundation of your completed house. The cost and effort to fix that, it just skyrockets. So this approach, it saves a ton of time and money. It keeps things organized, and most importantly, it makes sure the final product is exactly what it's supposed to be.
Okay, let's dive into those first two levels. We're heading back to our construction site to look at the most fundamental parts, the bricks and the walls.
The very first level is unit testing. This is where we're checking the bricks. In software, a unit is the smallest possible piece you can test, like a single function or a button. And who does this? The developers themselves. They write a little bit of code and then they immediately test it to make sure that tiny piece works perfectly on its own before it gets mixed in with anything else.
All right, so once we know our individual bricks are solid, what's next? We start building walls. This leads us to our second level, integration testing. This is where developers start combining those individual units, or bricks, to see how they work together. Does the login function actually talk to the user database? Does the shopping cart update the inventory correctly? We're basically making sure our bricks fit together to form a strong, seamless wall.
So, our walls are up, the structure is complete, the house is built. Now it's time to inspect the final build, not just from a technical perspective, but also from the point of view of the person who's actually going to use it. And this brings us to our last two levels, which are really important to tell apart: system testing and acceptance testing. Think of system testing like hiring a professional home inspector. That's us, the QA team. We come in and check the entire house, the plumbing, the electrical, everything, to make sure it all works together as a complete functioning system. Then, after we say it's good, comes acceptance testing. This is the future owner's final walkthrough. The client or the end users get their hands on it, and they decide if the house actually meets all their needs before they officially sign off and move in.
Let's make this super concrete with a real-world example. Say, an e-commerce website. First, a developer writes the add to cart function and unit tests it. That's our brick. Then, during integration testing, they check if the cart wall correctly connects to the payment wall. Next, the QA team steps in for system testing, going through the entire shopping journey from logging in to adding items to checking out. And finally, the client does acceptance testing to confirm the whole process works for their business. See how it flows?
Okay, so understanding all this isn't just for fun. It's an absolutely essential part of any QA professional's toolkit. So let's put it to the test and see how this knowledge can help you nail a job interview.
First question, the classic. An interviewer looks at you and asks, what are the 4 levels of software testing? Go ahead, take a second, see if you can name them.
That's it: unit, integration, system, and acceptance testing. Or, if you want to really impress them, just think the bricks, the walls, the house, and the owner's final inspection.
All right, next one. Let's get a little more specific. Who's responsible for testing those individual bricks?
You got it. It's the developers. I mean, it makes sense, right? They're the ones building each tiny component, so they're the first line of defense to make sure it works right from the get-go.
Now for a really important one, especially for us. As a QA tester, where are you going to be spending most of your time? At which level does the QA team really shine?
We are the masters of system testing.
Our job is to be the expert on the entire application. We make sure the whole thing works together seamlessly, just like a real user would experience it. That's our domain.
Look, if you take away just one thing from this entire explainer, please make it this right here. The house metaphor is your secret weapon. Bricks are unit testing. Walls are integration testing. The finished house is system testing. And the owner's inspection? That's acceptance testing. You lock that in your brain, and you've basically mastered this whole concept.
And that brings us to a final, pretty interesting question. We know it's the developer's job to test those foundational bricks, but how? What does that actually look like? What tools do they use? Well, that's a story for our next explainer. I'll see you then.